bad, but you don't know what to do with it, right? So that's another type of thing. The last talk that I gave here addresses that to some degree, which I'll touch on briefly in a minute. How to judge time to delivery. That's another skill that makes a good developer, right? Also on the topic of code quality, and that also raises the question of best practices and so forth. How to anticipate, discover, and solve problems, which we've already covered, and so forth. There's a lot of other skills that make a good developer, but it's easy for us to focus a lot more on that top point, on the actual technologies and just making sure that people understand that. But that's not like really the main skill. Now, why do I say that? Why might it be that the technologies that we're working with aren't the primary skill of a developer? Yeah.
So I always say, like, you could pretty much retype the application over the weekend. So most of what goes into it is the thinking around that.
Yeah.
I don't know. So, and that's like independent of the technology. Maybe you're thinking about technologies,
yeah.
but
so that's one reason. Most of what goes into an application is the thought process, not the actual specifics. Any other reason?
The tech changes all the time.
The tech changes all the time. So this space moves so quickly that focusing too much on the specifics is kind of missing the point. What you want is you want people who are getting pretty good at this stuff down here. You want to find people who know how to assess the quality of code, regardless of which technology it's in, who can determine what may qualify as an improvement. You want people who can judge time to delivery. You want people who can anticipate, discover, and solve problems, and so forth. You want people to communicate, and you want people who have learned patience and have some ability to forecast future problems before we encounter them and maybe head them off, or at least make an intelligent decision about it, and so forth, right? So we want to spend a lot of time actually thinking about these things in this field. And we want to be deliberate about our own growth in these ways as developers. Now that we've started learning the basic technologies, or we're a few years in, or whatever, these are the big things that will amplify our skills and really allow us to progress. So this is a quote that was in my last presentation that was on a similar topic, and that is, good judgment is the result of experience. Experience is the result of bad judgment. And so we end up in a situation like this where we learn by recursions of failure. Where we type something down, we get something down, we think, okay, this is close to what it should be. Then we get an error message, and we're like, okay, what was the problem with that? We fix it. Like this is how we learn. We learn by recursions of failure, and there's no way around it. But maybe there are ways to optimize that loop, right? So we're going to have those failures. We are hopefully going to learn from them, but we can maybe cache or make use of the existing caches of experience that other people have laid out for us. And as we earn our own experiences and draw our own learned lessons from them, it might be good to cache them for ourselves, remember them, encapsulate them somehow, possibly even share them around, right? Start a blog, tweet out a little insight that you just had. And it helps people to latch on to an idea that it might have taken them years of their own hard recursions of failure to learn, right? So this is an important way that we optimize the loop of learning. We want to identify what are all the things that we've left unsaid. Like, for example, all those intuitions that we pick up as we gain experience about the quality of code or about how to problem solve and so forth. We want to focus in on those. Well, I'm not comfortable leaving these as mere intuitions, and I'm just accidentally good at debugging. I want to figure out what it is that I'm actually doing and what I'm doing right. And maybe break this down to something I can do more deliberately and something that I can pass on to somebody else when I'm helping a junior developer through a project or whatever, right? So we end up with situations like this. Now, good situation, like a list of common code smells. This is a list from the book Refactoring. Who's that by? Mark Fowler?
He just did a new version of it.
Yeah, he just did a new version that has JavaScript code examples, by the way. Do pick that up. It just came out last November. Really good. Also, when you buy a copy of the book, you'll get a login access to get a permanently updated version of the book online on their website. So even if new editions come out and make improvements, you'll still be able to access it through the website if you buy the book. So just a little helpful tip there. But we end up with things like this, lists of code smells. We end up with lists of design principles that break down for us some pattern or some intuition that someone has realized, that that's something that I can actually quantify or qualify, write it down and explain what it was that led me to this thought process. And then we can wrap a term around it like primitive obsession or shotgun surgery. And then if we learn these terms, then we can recognize those things when we run into them. And books that include these things will have like suggested refactorings. And they'll have a term for a type of refactoring that might be a good way to solve some of these problems. And these are learned experiences that we've cached. We're making available to people. The design principles like drive, sometimes called the single point of truth, or solid, which is Kevin Hinley suggests cuts down to single reason to change is the main concept there. The law of Demeter, also known as the law of least knowledge, where one class should know as little as possible about any other class. Low coupling, which is the concept of relative independence of modules or units in your code. High cohesion, which means that a unit of code should do one thing well and focus in on that one thing. And then connascence, which, as we talked about in the last talk, kind of sums up all of these, and it discusses different kinds of entanglement within your code and how you can identify those and maybe some suggested ways of reducing the entanglement, the spaghettiness of the code. So these are all really good in terms of looking at one set of skills that are often sort of left less focused on in the development community. But we want to talk about debugging. So debugging or problem solving, I'm going to loosely define this, describes not only the problem solving of bugs in production code, but also the problem solving of progress blocking bugs at development time. And so that latter one is more the one that I deal with on a daily basis with students, but both types of bugs are things that are blocking in some way that we want to learn how to overcome more effectively. So I am loosely defining the bugging there a little bit. So what we need is an approach. We want something that we can hand to somebody and say, why don't you follow this and maybe it'll help you, right? We don't want to just say, the problem solving, right? We want to talk to people about ways that they can problem solve. It's not good enough just to sit them in a room. Eventually, they'll come up with ways to problem solve, but we want to bring this down to something, an approach. So here's the scaffold that I'm going to propose. This is a really universal scaffold. This scaffold we will use for the debugging process itself, but we'll also use this for the educational opportunity of debugging itself. So the first is prepare, the second is monitor, and the third is review. And these are stages. These are actually temporal stages in the process of problem solving that we ought to be bringing deliberately to major problems when we encounter them. So when I am dealing with a big problem, I should stop and think, okay, well, this could lead into 2 hours of me staring at my machine, or I should maybe be a little bit more deliberate about this and follow an approach. So this is a very bare bones way of doing that. I need to prepare. So, and then we'll go into some details about what that is. I need to monitor my progress as I go. I need to then review so I don't lose track of what I gained and what I learned about this process. And then we can apply the same thing to when the problem is, I want to help this junior engineer learn how to debug more effectively. So in that case, the problem is, I want to sit down and help them overcome this challenge. So the problem isn't exactly, I want the challenge that they have to be solved. My problem is, I want them to learn how to do this for themselves next time. Does that make sense? So my way of approaching the scaffold in that scenario is, before we start the debugging process, we prepare and we go through some preliminary questions and we lay some things out and make sure that we're communicating effectively and so forth. And then I move on to monitoring. And then I move on finally to review. And after we've solved the problem, we stop and we look back and we discuss it. So preparation might look like something like this. What did we expect this code to do? What did we get? Did we get any error messages? Did we get some unexpected behavior? And what did we try? We want to lay all these out. Don't just like throw me into the problem. Let's discuss this for a minute. I don't want to even see anything. Let's just talk through the problem a little bit, understand what's actually happening here. How do we reproduce the problem? What has changed recently? What aren't we sure we understand in this problem? Well, maybe that's an opportunity to look it up on MDN or whatever, right? Like, you want to make sure that we go through some of these preliminary things, because so often you'll get into the middle of the debugging if you've not done any kind of preparation work at all, getting into the discussion, and then you realize they didn't know how to use get element by ID or whatever it is, and they're expecting the wrong return value or something, right? So we want to get a lot of these things out of the way. And do we have any hypotheses as to what the problem might be? So sometimes we might even, in really severe problems, or when we really want to model breaking things down for somebody, we might even write down the answers to this. Or if you're approaching a really serious problem and you've been stuck, and you want to be sure to get through some of this stuff, yes, even just writing this stuff down can be extremely helpful for you. And there are all kinds of other questions that we might think to ask in the preparation phase, whether that preparation is for me to solve a bug that I'm attacking, or for me to help somebody else learn how to debug. And then we have monitoring. So the main thing here is that we want to keep an eye on our progress. So what you want to do is you want to have the discipline to be able to identify when you're just staring at it and spinning your wheels. Right? That's the most frustrating time for all of us. And it's not helping us. Right? Just staring at the code doesn't solve any problems. How many of us have been stuck just staring at code for way too long before? It's embarrassing. We've all been there. It's a pain. So what we want to do is we want to discipline ourselves to monitor our progress. And if we find ourselves falling into any rut like that, where we're just staring at it, we're not making any progress, that's when we go back to a list of strategies or whatever, find another perspective, find another approach, and re-tackle it. Don't just stare at the code. So some early things that we want to get out of the way are things like errors are data. This is an attitude change. Errors, we like errors. Errors are information about the problem. They're good. The problem is a challenge that we want to overcome, the information, but give me all the information. Right? I want to see the errors. I don't want to avoid them. Really early on, code learners will often avoid the errors because they're red and they're scary sometimes. But we want to embrace errors. We don't want to be frustrated by it. You're not going to be working your best if you're angry at the errors, right? So we want to change our attitude about errors. Errors are data. Errors are information. Errors are good. We like errors, and that's a place to begin. That's one place to begin, right? That gives us some stuff to go on. Another big thing that can really help, especially with juniors writing code, is tidy up the code. Like sometimes the problem just comes down to the fact that they've got a nested loop and the iterator in the outer one is I and the iterator in the inner one is J, and then confuse which is which in the middle, right? So rename those variables, row index and column index. Then they mean what they actually are, and you can read the code more lexically. It's more readable, you can understand it, you can comprehend it. There's something that I tell my students about, and that is this concept of the magic number 7. Anybody other than my students or former students know what the magic number 7 is? The magic number 7 is this idea that sociological studies have given us, where we have this capacity as human beings to hold in active memory about 7 plus or minus 2 things at any one given time. So what happens when you write your variables like I and J and N and D and C and X, and you've got all of these things that actually, they're useful, but they don't mean anything. You're having to hold them in active memory. And that blocks you from absorbing other things into active memory and overcoming those challenges, right? You may be missing part of the picture just by virtue of the fact that your code is less readable than it could be. So often, one important part of refactoring is, of debugging, is not actually working on the problem directly at all. It's working on your problem of possibly not understanding the problem itself. So let's clean this up. Let's refactor this. Let's make it more readable. Let's reduce the number of things we have to hold in active memory at any given point. Let's pull this out and make it a function and call it this, because we know this works and we can validate that this works. So let's just pull it out. That's one way to do printing on the page, and we'll make a print on page function. Then we just can look at that name and then we know what it does. We don't have to hold the whole algorithm in our head. Right? So tidying up is a big thing. Validate your usage of key features. Of course, I already mentioned this a little bit. Like sometimes in the prepare stage, we realize that the student admits, or the junior level developer admits, that they're not 100% confident what this method does or what this feature does. Well, let's get that out of the way early on. And let's just make sure that we understand what we're using. Let's look it up in the documentation and model that. Don't tell them this is what this does. Model it for them. So how would they find out what it does? Well, if you just tell them the answer, you're modeling that they should come to you for all the answers. You don't want to do that, right? You want them to look it up for themselves and be able to be comfortable with that. So, all right, let's see what this does. Right? Pull it up. Pull up a code example. Toy with it in a REPL. Let's confirm this does what we expect it to do. Right? And that's something that you can apply yourself individually. Am I 100% confident when I'm working on the bug that the features I'm using are in fact working the way that I expect them to work? Break it out on REPL, break it up in the documentation. It's a big part. Explain the code simply. This is the famous rubber duck. For those of you who may not be familiar with the rubber duck, the story goes that a developer one day got up from his desk with a problem, walked 10 feet over to another desk and talked to another developer and said, hey man, let me tell you about this problem. And he just started rattling off an explanation of his code. And by the time he got to the end of the explanation, he was like, you know what? I just realized what my problem is. He went back to his desk. And he did it 3 more times. The last time he goes to the other developer's desk, he says, man, you've come to my desk 4 times, and never once did I even have to jump in and give you any advice. You figured it out on yourself just by trying to take the problem and break it down simply in English words. So why don't you take this rubber ducky and take it back to your desk, and next time you get that urge, talk to it, explain it to it. I've got another friend who just goes home and calls his mother, and she just loves hearing him rattle on. She doesn't know or understand much of his thinking, but he just tries his best to break down the problem in some way that is close to what she will understand, and then so often he'll just realize what the problem is. So this is another critical and very popular way of dealing with problems, right? And in the challenge of helping someone else overcome their debugging challenges, this should be built into the process as a part of the preparation stage. Describe the problem and explain your code to them. Just don't even talk about the problem. What were you trying to do? What does the code? Let's read the code together. And occasionally, let's read the code backwards together. And see, start from the output and then go back in time and see if we can figure out logically what's going on. So explaining the code, reading the code, forward, backwards, whatever helps. These things are really helpful, but the big trick is to do it as simply as possible. And then rule out stuff. This is problem space reduction. Well, where does the problem live? Well, I have no idea. Well, if you can identify major portions of the code or the overall application or any interactive applications that might affect things, if you can rule those things out, then you've ruled out massive potential places where the problem could be, right? So rule things out. Sometimes That even means just commenting out code, just like wholesale. Like, I just want to make sure that none of this is affecting what I'm working on at all. Right? Write tests. Don't know what's going on in your code or why? Well, write some tests. It does a few things. One, it gets better test coverage in your application. Two, it gives you an approach to thinking about what the possible values of everything in your code could be, right? It gets you actually thinking very programmatically about all the things, one by one, and what could this be, and am I taking into account all of the edge cases and so forth, right? So writing tests isn't just something that you just throw in because you're supposed to. It's actually a very useful scaffold in its own right for approaching a problem and trying to identify what may be wrong in my code. And certainly it tells you more about your solution. More tips. So break away. Let your wonderful subconscious pull some of the load for you. So sometimes you just need to step away from the code and you just need to admit that. It's not going to be super helpful for you to just bang your head at it for hours on end. There comes a point, and you should lean a little bit towards the earlier side rather than later, where you need to just step away, break away from the code, break away from the problem, and don't break away to go think about it. Break away to think about something else or just to let your mind wander. And trust your subconscious to do some work for you, because your subconscious is amazing. Your subconscious will do a lot of work for you, and I can't tell you how many times that problems that I've encountered will just suddenly find a solution, just popping into my mind like in its own right without me working terribly hard at it. Because the subconscious works, if you read, I didn't think about this for this talk. There's a really great book called Willpower by, I think it's Roy Baumeister, which is an interesting book on psychology's perspective on how will and willpower actually works. Really fantastic work. I do recommend it in general. But they talk about how the subconscious actually, the way it works is it's kind of got this track system, and it's actually going to be working on tasks, thought tasks that you've started one way or the other. That it's trying to complete. It's the reason why we get the earworm. The earworm is the term for when you get a song stuck in your head. It's because at some point in your environment, or maybe you whistled it to yourself or something, somehow or other your brain got started on the task of the song. It didn't complete it. So your subconscious is just going over it trying to complete the song. It's the reason why the easiest way to get the song stuck or out of your head is to go and listen to the song in its entirety. So yes, sometimes you need to go and watch the music video for Justin Bieber's Baby, just to get it out of your head. And I'm telling you, it will work. It works. You watch the video, you complete the task, and your subconscious is satisfied, and then lo and behold, it's gone. Right? So your subconscious is doing a lot of tasks for you. Sometimes just trust it. And go take a break, let your conscious mind rest a little bit, come back to the problem. Sometimes you just need to break out. Get away from the code again, but this time go to a whiteboard, go to a piece of paper. Sometimes this is similar sometimes to just talking it out with a friend, like the rubber ducky thing. But just get away from the code for a minute and think about it in an entirely different way. One of the nice things about paper and whiteboards is that it gives you an opportunity to think about your code spatially and graphically. And you can chart things out. You can draw lines between relationships, and you can really work on it. It's a huge thing that I recommend. Get away from the code and actually try to find a different way to visualize and represent the challenge that you have. And then that again is a really good one for when you're helping somebody overcome a problem. Right? Break it out. Let's think about this in a different way, especially if you recognize that the problem is a logical one. Again, you don't want to just give them the solution, because you're modeling to them that they should come to you for the solution. What you want to do is you want to try to find a way to pierce through to the solution in their mind. Get them to think of the solution. Or barring that, maybe give them the solution and then try to reverse engineer that solution. Like, how might we have discovered this? If if I didn't already know the answer. Just try to find some way to bridge that gap between here's the problem, oh, here's the solution. I'm just providing for you on a platter, right? All right, and then we want to break the code sometimes. Break the code. See how the tests behave. See how the application behaves. All of these are just examples of trying to get more information. This one especially is useful when you just have no clue what's going on. I have no clue what's going on. Let me confirm that my tests are working. Let me confirm that this is working as expected, or whatever the case may be. So let me just arbitrarily break things and see how the application behaves and see if suddenly I get the right thing out of this thing that was giving me the wrong thing. Follow the data flow. So this one you can do logically partially. So pick a value and follow its lifetime through the application, through the function. And make sure that we understand what it is at every point. What's it doing? Is it mutating? Where's it going? Right? Who handles it? Follow the lifetime of a piece of data. And so associated with this is using some tools that make that easy, obviously, like the debugger. The debugger is really useful for this. Throwing in a console.log, not always the best way to do it, but as an example of this. But try to be consistent with it. Approach it as a strategy, not just let's peek at it here, let's actually follow it through, forwards or backwards or whatever, and make sure that we understand how this data is being handled and how or whether it's being transformed. And then, of course, now this one is especially valid for those of us working in dynamically typed languages, and that is check your types. Make sure that because with dynamically typed languages, the most common errors tend to be type-related errors, so we want to make sure that we keep a very careful eye on those. One little tip, if you're not working in something like TypeScript or another strongly typed language, is that you can actually use the TypeScript compiler and disable the TypeScript features and just let it check your types for you as another pass of validating the consistency of your code before it outputs JavaScript. So you're giving it just vanilla JavaScript. It's just going to output vanilla JavaScript, but it's actually going to do type checking for you, even if you're not using the TypeScript features. And that could be a way in your code base that, on a team that doesn't usually use TypeScript, where you're not wanting to commit TypeScript, you want to commit JavaScript. Well, you'll still run it through the TypeScript compiler and get some benefits there. Another tip is sometimes, especially on simple problems, hard code a solution. Hard code a solution, write maybe some tests to validate that it works, identify the patterns in the solution. What do I need to break out? What do I need to do multiple times? And so forth. This one is maybe a little bit more useful for beginners than it is for those of us who are a little bit more experienced, but it's still a valid point. Sometimes when an early language learner is stuck on a problem, just write out, print the number 1 on the page, print the number 2 on the page, number 3, and then help them reflect on, do we see any patterns here? And what can we improve on this? And how can we take this very repetitive thing and make it something better? And then one of my favorites is refactoring. So this is the sort of thing, this is one of the last resorts kind of thing, unless it's only like a small function. But sometimes the problem is just in your implementation, not necessarily in the logic. You may not be clear where the breakdown is between the implementation and the logic. So sometimes just re-implement another function that does the exact same, or is supposed to do the exact same thing, same inputs, same output, but just write it using a different strategy, different algorithm, just a little bit of a different way of doing it, and then see if you still have the problem. See what you can learn about the problem space by doing it a different way with the same inputs and same outputs, same effects. And then finally, for monitoring, and this is my biggest tip. So it's got its own full page. If the problem is not found where you thought to look, then the problem likely will be found among the things where you have not looked. that make sense? If you looked everywhere you thought to look for the problem and you can't find it there, well, probably it's not there. So it's in your assumptions. Somewhere in your assumptions lies the problem. So this is something we can be very deliberate about. When you're just stuck and you have no idea what is happening. I've tried everything I thought to try. Okay, so let's rule all those out for now. And let's start enumerating our assumptions. Let's start listing down the things that we're assuming are true. And then prove them right. So, and get super molecular about this. Like, I assume the file is saved. I assume there's no caching issue. I assume the server properly restarted. Whatever, right? Like, whatever it is, start writing them down. Or list them out and just start proving them right. And start with the simplest to prove, like saving the file. Sometimes the most annoying problem is I've spent 3 hours on a bug, and it's just because Maven didn't correctly install a dependency. That's the Java one, for example. Right? You never know. So you won't know if you don't start thinking about the things that you're just relying upon to be true. So this is one of my favorite strategies, and the number of things that are assumptions are going to be much larger for juniors, right, and early language learners. So getting them to handle those assumptions and deal with them, wrestle with them, and prove them, and think about them deliberately is a huge part of speeding up their progress as an engineer. And you can help them with this process, right? Help them think about, okay, well, what are the things that we're assuming? And sometimes that takes, again, a little modeling. Like, we're assuming that, you know, even if I tell somebody to enumerate their assumptions, they may never think about the problem of the file save, right? You know, maybe we recently turned off the autosave feature in VS Code just to toy with it. We forgot we even did that. We're just so used to the habit of it autosaving for ourselves. So look for that little circle on the tab, you know, make sure it's saved. You know? But so this is just this one in particular is really good for when you just have no fucking clue what's going on. You can have whatever. Right? So work it out. And then finally we get to the last stage, so review. So that's when you, as someone who is debugging, or you as someone who's helping someone learn how to debug, starts breaking down and asking ourselves these questions. What steps did we take? Regardless of how successful each step was, what steps did we take? And then, which steps gave us valuable information? Information that ended up being useful for this problem. Right? What clues, now that we have the power of 20/20 hindsight, right? What clues might have given us indications that this was indeed the problem and given us a potential path for investigation or a hypothesis? Right? So what we're trying to do is we're trying to reflect upon the process, not, oh God, yes, I solved the problem, I saved the day, time to move on to the next problem. Please don't do that. Stop. Sit in the moment for just a second. Think about the process that led you to discovering what the problem even was, or discovering what the solution was. Think about the steps that led you there, and see if you can learn from that process, so that when you encounter something similar in the future, hopefully, you can go, oh, you know what, this is like that other time, and this is how we solved that problem. When I was working with Jeff on this problem. Okay, well, I can just, oh yeah, that is the problem. Okay, right? We want to break these down. We're caching the learned experience. Does that make sense? For someone. How might we optimize this process? So what steps weren't particularly useful? What might we want to focus in on to optimize this process? Did this process of uncovering the problem also uncover any knowledge gaps that I could take away as a learning opportunity and improve on? Like, I guess I don't understand the DOM as well as I thought I did. So that's an opportunity for me to go and do some further investigation so that I'm more prepared to tackle similar issues in the future, right? How is this worth documenting? Sometimes that means a literal change to the documentation in your app. I hope you have documentation. Sometimes it means, oh, we need to write better tests, because tests are, in a sense, a form of documentation, right? Sometimes it means, man, this was a really interesting challenge, and I want, as a part of the review stage, I want to actually expound on this in an article, right? Put it up on Medium or something like that. Just the writing process and explaining it down and going through all of that can really encapsulate that learning experience for you. Or occasionally, you just send out a tweet at Bob Martin, whatever, right? So these 3 steps are the main thing, right? Being deliberate, following an actual approach, not just being haphazard, stumbling into problem solving, realizing that intuition is most of what you're doing. Don't rely overly much on the debugger. The debugger is useful, but the debugger is only useful for a few different approaches to actually solving problems and detecting what the problems are and so forth, right? So you are the debugger. Like, that's the real takeaway here. That it's your responsibility to take the process in your own hands, and you want to implement metacognitive disciplines. Who knows what metacognition is? Metacognitive disciplines. And metacognition is thinking about your thinking, thinking about how you're thinking. That's deliberateness, right? We're doing this on purpose. And so if we're really going to be deliberate about this, that's going to allow us to break things down, to be able to reproduce them more memorably for other people, and hopefully in the long run, really speed up the process of our teams. Like, if I just give somebody an answer, I'm speeding up the right now, so you think it's fast, but you're actually not speeding up their overall progress, right? So this goes down to something that Michael Feathers and Bob Martin and so forth have been tweeting about a lot lately, and that is that slow is fast, and fast is slow. Can someone unpack that for me?
Pay now, pay later.
Pay now or pay later. So an example of that is writing tests. Writing good tests on a complex application may be viewed as slow right now, but the idea and the trust is that it will speed up your overall work with that application, because it just rules out whole sets of massive debugging sessions that you would normally have had to go through in order to uncover problems. Writing your test to validate things are correct the way that they need to be absorbs a little time in the future, but actually speeds things up in the long run, right? So this is the same thing when you're working with a junior. Don't just give them the solutions. You want to help them and model for them the unpacking of the problems and actually implementing some metacognitive disciplines, some strategy to the actual issue that they're approaching. And so both for them and for you as the person that's helping them overcome can follow just a basic, simple way of breaking down the problem. Prepare for it, ask preliminary questions, make sure that we're on the same page, make sure you understand where they aren't completely sure of what they're talking about, make sure that they are explaining all of the behaviors that they're seeing and are pointing out the error that they saw in the log that they're ignoring and so forth, monitoring, making sure that you stay on the actual path of debugging. If you're just staring at it, you're not actually on the path anymore. You're in a cul-de-sac off in a neighborhood somewhere, and you're not making any progress whatsoever. So make sure you monitor your progress and try something new if you get stuck. And then finally review and talk it out. Like, what did we try? What worked? What was the actual, what were the steps that actually gave us valuable information, and so forth. So, any questions? Comments? So I would love if people give me some brilliant things to add. Yeah.
So, I was talking to a couple of my interns a couple days ago, and we were talking about a problem they had taken from 8 hours to debug. And I was like, about an hour into this, you should have come to me. Because like, debugging is like chess. When you're bad at it, you don't know where the end is.
Yeah.
play the entire game.
Mhm.
And so it's a lot like chess or Go.
Yep.
Hours. And, I forgot to say it. All right.
No, but that's a great insight. That's a bullet point worthy note is know when too long is too long, know when to go get some help. That's very pragmatic. Like spending 8 hours, even if it's only junior level pay, isn't time effective. Like get some help at some point. Yeah, for sure. That's awesome. Good insight. Yeah.
Maybe, I don't know how you could capture it and where, but one of the things I've learned in my time debugging is sometimes it's about, it all come down to what can I do different? Because a lot of times you're like
Yeah.
repeating the same thing and getting the same result.
Sure.
And then drawing attention to that
Yeah.
sometimes can help debug me off of a stupid idea.
Yeah, right. That's like a smaller example of the refactor.
Yeah.
Right? Like it may not be you're refactoring an entire function or class. It may be there's this one line, this one simple way of deriving falsy or whatever from this. Maybe there's another way to do it, and I should just stop like banging my head and trying this one way to do it. Yeah, that's a good idea.
I remember my thing.
Yeah.
Start with the student. So if you thought it can't be that, start with it.
All right.
Because the problem ended up being like they just were writing it in the wrong library.
Oh, right.
Like they had copied the requirements and they
Okay.
didn't change the thing. So it had the right variable name over here, right?
Right.
That's Slack, but then over here it was the wrong one. They took them 8 hours to realize that. I was like, start to copy your file.
Mhm.
And you have it in there, you know, to rule things out. But,
Yeah.
Usually
IDF
you
can
start
help
with
with
the
that too.
important things.
Yeah.
And so obviously start with
Yeah, very cool. Any other ideas? Tips, or even tips for helping somebody else? Yeah.
You mentioned briefly reading it backwards.
Mhm.
That's an old editing trick, right? So you've read your paragraph,
Yeah.
you're writing essays, right? You read your paragraph, and you read what you want to have written, right? Not what you wrote.
Yeah.
So if you read it word for word backwards, if you read your variables backwards, maybe you misspelled a variable.
Yeah.
And the debugger just sucks giving you a good output.
Yeah.
Or maybe you missed a semicolon.
Yeah.
And you're stuck in IE8 and it's really terrible.
That's exactly.
Things like that. So reading it backwards makes sure that you're actually reading every
Yeah.
character, every line.
I'll be the only one giving suggestions, but read your code out loud.
Read your code out loud.
It's the same thing when you're editing or writing comments or
Yeah.
does this tweet sound dumb, or read it out loud. And that
Yeah.
means say when it says semicolon, say
Yeah.
semicolon, and also just read it out.
Yeah.
I had to do that about a month ago with a guy.
Yeah.
And we both found the bug at the same time. So we're like, that's not right.
Yeah.
It's like an extension of rubber duck.
Yeah, for sure.
Just kind of good.
So along the same lines, I had a friend who, especially when they wrote big code blocks or comment blocks, because you usually don't have spell check in your code, highlight the whole thing and have the computer read it to you.
Oh,
So if it doesn't sound right, most likely
Yeah.
it's not right because the
Yeah.
computer's pretty smart.
that's a cool idea.
So
For sure.
He talked about either rubber ducking or explaining your code to someone else, even if they have no idea what you're talking about. But in terms of like reading your code out loud, sometimes, I won't say like this function does this, like this line does this line does that. Like I have to break it down line by line, and then it's like, oh, okay.
It also helps you find out where you should be naming your variables and functions. For I, blah, blah, blah. Same thing, if the function name is 1, 2, 3, 4, 2.
Yeah.
So if it doesn't read like a sentence, usually, in my opinion, it's
Yeah.
not really good. Code is comment type stuff.
Now, I'm actually, so we've joked a little about using I and for loops. I'm kind of a purist with that. I never use I. I know I'm the extreme minority.
There's an
Give
ES
that
limit
way.
rule for that now.
Sorry?
There's an ES limit rule for that.
Can you guess what it was?
Should have turned on.
Yeah, so I always use, like, there's an actual, like, distinction between the concept of an index and an iteration and a count. So I just use the word that actually corresponds to the thing. And if it's something that can be explained a little better, like row index, then I use row index. Then there's no room for confusing it. And hopefully it's reducing one more thing that you have to juggle in your magic number 7 that you're keeping track of in your head. So I tend to be a purist in that sense. Of course, I don't grade my students and require them to use spelled out variables. Like, that's not part of their thing, but I do talk to them about it. Like, spell it out. What is the variable? What's it actually do? What's it actually mean? We'll say it there. What's that function? What's it mean? Well, make that function name a little longer, but it explains itself.
All right, let's do the last one. But actually, I'm going to talk, I believe, in February about reducing code complexity. One of my main points is special knowledge is bad. And so variable name of I is a classic example of special knowledge. So if you just see a piece of code, it's got I and R and J and K, you have to ask somebody what it does.
Yeah.
That's special knowledge, and that is cancer to your code.
Right.
And so that's just, you don't have
It's
special
magical.
knowledge. Yeah, it's magical.
Yeah.
I use special knowledge because, the old man, she had a crystal on that. But anyway, yeah, special knowledge is magical, so avoid it.
I like you have the thing about breaking the code, and I know some of the times that I've just spun or seen people spin for a long time, it's like they're solving a complex problem where there's maybe multiple problems. Like they might be updating code and something in the build process is wrong, and the code they're updating isn't even the code we're testing.
Yeah.
So explicitly breaking the code, I'm just going to throw an exception in line 1. If I don't see that, why am I looking? I'm looking in the wrong place. And kind of a corollary to that is do the simplest possible thing that will work. Someone mentioned we had a require that pulled in the wrong library. What's something that should no complexity? I'm just trying to access this attribute and it's not there.
Yeah.
It's kind of helpful.
So you mentioned the distinction between bugs in code development and bugs in production. I think it's kind of interesting, so the monitor step, I think it's different, it's still there in the production side. Complex systems running in production can get weird. You still do monitoring, it just is a different kind of thing. Yeah. Okay, I work for sells an application monitoring tool, so that's why it's top client. But there's a lot of times where we're looking at an exception happens or alert fires, and we're looking at cracks of data that tell us about how the system is functioning now that relate to the bugging question. I just felt like your framework applied in that way, but not quite the way they talked about.
Yeah. So there's a lot here, and I'm only just beginning to tease out this little scaffold. And so insights like that are fabulous. Sure. And maybe we can find an even better scaffold. Something that, doesn't have to be 3 steps. These are really simple. Obviously, review monitor or prepare monitor review. Those are super simple. These are just things that we should do all the time for things when we want to be deliberate about things. But maybe we can find even better ways to describe what an approach might be. Yeah.
I just kind of add on to that error reporting and alerting is kind of should be a feature of the application.
Yeah.
Otherwise, it goes into production and you get some generic error. If you haven't taken the time to put stuff in place that gives you the correct information about the error, you're not going to be able to figure out what caused the log. Doesn't matter how many logs you have if the right stuff's not in the log. So I like that idea of taking time to make sure your program errs in a way that's helpful.
Yeah. Sort of live somehow or other.
It's only part of your review process. If I knew this, earlier in the process,
Yeah.
I could have found this bug a lot sooner
Yeah.
versus it getting caught up in a try catch or something like that and just disappearing.
That's right.
Very specific tip along those lines, actually, when you're using exception monitoring tools. A lot of times I will do a thing where I will capture specific exceptions that I know are going to happen, and I will add extra information that is not in stack trace, but is contextual to whatever the thing is, and then raise that error again, or send it directly to the monitoring service, so that when you get that exception, you know, not just line of code and some steps and stuff from the server, but also like which user ID was, or what the input was that might be a relevant problem. You have to be careful about not putting like sensitive information in there, but it's always safe to like IDs and other sorts of things to help you focus on whatever relevant inputs for the thing.
Another technical approach. Anyone tell me why git bisect might be useful for debugging? When did the change happen that caused the bug? Maybe the change isn't a recent change. Maybe it's something that happened, 2 years ago. But we only are now noticing that there's a problem with this. Well, where did the change occur? You don't know exactly. Git bisect allows you to essentially do binary search on your commit history. So let's, go back in time this far, and then does the error still occur? Well, if the error still occurs, then it's even further back in time. If it doesn't occur, then we go this way, and we have it. So we do an actual binary search on the commits to narrow down where exactly was this bug introduced, which is super useful.
You can do a whole nother talk on just making sure you have meaningful commits.
Yes.
So you can find
exactly.
those kinds of changes.
Yeah, meaningful commits are so useful. And that, there's another thing that maybe a lightning talk that I'm preparing on how to learn a new code base or legacy code base or whatever. And one of the tips is if they've got a commit history, go and read their commit history. Learn about the changes as they've evolved, the history of the application. Familiarize yourself with how that evolution took place. And that's only possible if you have sensible commits. Sure.
And a good tool for keeping those commits, right? Use Git, don't use anything else.
More SVN.
You mentioned like coming up with a hypothesis of like what could be wrong, and that's something like when we have complex issues, a lot of times I'll just get as many people that have ideas and say what could cause what we're seeing today, and just brainstorm like as unbounded as we can, and then have people come through and say what experiment can we run to prove or disprove these, and just assign them out. Or have people like run through those and eliminate things so we can sort of narrow in. And that sort of like 6th grade science fair approach of, we think this might be happening. What can we do to prove it? And do that and just keep iterating through.
Yeah, and I would emphasize being willing to even bring up things that are a little implausible.
Yeah.
One of my favorite things, and I do this all the time in meetings at work, is I follow what I call the Riker principle. And so Commander Riker and Star Trek Next Generation, and one of the movies or one of the episodes I haven't been able to find a clip on YouTube, and I'm afraid I'm going to have to go back and watch the whole series again just to figure out where in the world he said this. But he describes his role as a first officer of the Starship Enterprise when he's on the deck at the same time that the captain is. As a situation where when the captain has an opportunity, goes to make a decision, his role is to identify at least some alternative. Even if the alternative is implausible or ridiculous, his job is to find some alternative, some kind. And it may be, I can't think of any alternative other than running the ship into the other ship, right? But that's his job, and he's not getting in trouble for giving the alternatives. That's his job. Like, I'm just thinking of something. This might be stupid, but this is the only alternative I can think of. So that's also a really useful tip for making sure that we're being thorough thinking about solutions, whether that's in debugging or otherwise.
Question, not from a junior standpoint, but more maybe mid-level, where do people usually go wrong?
Sorry,
From a mid-level career perspective, where do developers go wrong?
where do developers go wrong at mid-level?
From a debugging perspective?
Yeah,
Assumptions.
Assumptions?
Fatal assumptions.
Assumption experience.
We know these things, but are we forcing ourselves to? We know these tricks for debugging, but are we actually using them? Are we actually stepping away from the code,
Right.
going over to a white?
Right.
We know what we should do. Are we doing it?
So you're saying we're not being deliberate about
Right.
Which I would go with assumption, you're assuming you know what you're doing.
it? Yeah, that's right. You think you're hotter stuff than you actually are.
Well, and along those same lines, you want to prove that you're hotter stuff than you actually are, so you're less likely to step away and ask someone when you're like
Ego.
totally lost.
Get like too bought into your approach.
Yeah. So you might burn 2-3 hours on something where you should have at some point been like, I need an extra set of eyes. I need a rubber duck to talk to.
Yeah.
I need something.
So now this gets a little philosophical, but I view that as not, so the ego getting in the way of identifying problems is, in my mind, disingenuous.
Mhm.
Because the entire experience of being an engineer is we swim in bugs.
Mhm.
We swim in failure. Like that's, when you start a project, you don't have a working project. The whole process is one incomplete part of the application after another, and the whole process is running into unexpected behavior all the time. So the healthiest thing that we can do is just to be really open about uncertainty and about failure and embrace it, because it's a part of the learning experience. It's those failures and accepting them that gives us the learning experience itself. And so that's one of the things I really love about software engineering, is because to really do it well means that you're embracing the uncertainties and the failures that you encounter in your experience, and that really speeds you on. So it's a necessary part
Mhm.
to really ramp you up to another level of the experience. That kind of humility and that acceptance of, like, this is what we do. This is the water that we breathe.
Well, the description as a middle tier or a mid-range engineer, I find that certainly to be a part of how you get from mid to senior, is recognizing, oh yeah, I don't know it all.
Right. Isn't that like on every classic baseball movie? Is
Mhm.
the new hot shot that has to learn
Yep.
that, yeah, he's good, but there's still things to learn.
Yep.
Don't let it go through your head. Well, feedback is UAT, user acceptance testing. So if you have more things about this or insights about how this went off, please do reach out to me. I did add this one because I know my audience, Indie Hackers Slack team. If you're not on that, please do Google Indie Hackers Slack invite. There's a little Heroku app that will auto invite you to the Slack team, which is really useful. And then again, if you want to get back to the slide deck, there's the link. Take pictures if you need to. Otherwise, I'm done if you're done.
All right, guys, that's everything that we have. Just as a reminder, or if that motivated you to come up with some idea, next month we are doing lightning talks. So if you want to do something short, shoot me a message on Meetup or talk to me after now or right at the beginning of next month, and we'll become one. And I think that's it. Thanks.
Yeah.